Welcome. Today we take few problems on the chapter function. First problem is the period of the function 3 to the power sin x 3 sin x plus 2 cos x its mod plus 1. The period of that function fx is equal to that. So options are pi by 2, pi, 2 pi and 4 pi. Actually, this function, which is in power of 3, it is periodic. So its period will be period of the function fx because 3 is constant. Now we know that for first part 3 sin x, its period is 2 pi because period of sin x is 2 pi. And 3 is constant multiplier, so it is immaterial. Similarly, that 2 is immaterial, and mod cos x, its period is pi, and it is constant. So, period of that function is LCM of this and that, which is equal to 2 pi. So, period of fx, that is 3 to the power that, is 2 pi. So this is our correct answer. Next problem. The period of the function fx is equal to sine 2 pi x by factorial 5 plus cos of 2 pi x by factorial 7 is. Options 35 factorial, 12 pi factorial 7 and factorial 2. In the present problem, fx is sine of something plus cos of something, both are periodic. Therefore, we have to calculate period of this and period of that, and after that to calculate LCM of period of this and that is answer. Now it is of the type sine. First one is sine AX, its period is 2 pi by A. 2 pi sine x, period of sine is 2 pi, and by A means coefficient of x. In this case, this period of that part is 2 pi because it is sine function by coefficient of x, that is 2 pi by factorial 5. By same argument, coefficient of that is 2 pi by 2 pi by factorial 7. that is 2 pi cancels, it is factorial 5 and factorial 7. Its period is factorial 5, its period is factorial 7. Therefore, the period of this whole function is LCM of this and that. LCM of this and that. Now, LCM is factorial 5 and factorial 7. Their LCM is simply factorial 7. So, answer is factorial 7. C is correct option. Now, next problem. The period of the function fx is equal to e to the power 3x minus integral part of that is also 3x. The period of that function is how much? So options 1, 3, 1 by 3 and 3 pi. The power actually it is 3x minus integral part of 3x. That is, it is of the type x minus integral part of x. That's it. That is decimal part of this. It is decimal part of that. So we know that decimal part of for function, if function is x, it's that is simply is denoted by integral part of x. Sorry, this is decimal part of x. Its period we know 1. And period of this will be the period of the function fx. So now you see 3x minus integral part of 3x, its period is 1 divided by 3. You can verify it. Suppose this is fx. F of x plus 1 by 3. I am telling that this is period of this function. So fx plus t, it is equal to 3 of x plus 1 by 3 minus 3 of x plus 1 by 3. It is equal to 3x plus 1 minus 3x plus 1 integral part. But integral part of that is equal to integral part of this plus 1. So that it is equal to 3x plus 1 minus integral part of 3x minus 1. They cancel. Therefore, it is equal to, you see, fx. Fx plus t is equal to fx. So t is the period of that function. So 1 by 3 is period of that function and it is constant. So period of this function is 1 by 3. This one is correct approach, correct option. Next. Now this problem is for a range of a function. If fx is equal to x by 1 plus x square, then the range of fx is options -1 to 1, minus 1 by 4 to half, minus 1 by 4 to 1 by 4, and minus half to half. Acha, range means we have to find for all values of x in domain of definition of the function its minimum value and maximum value. If minimum value is a and maximum value is b, then a to b, it is the range of the function. In fact, this is a quadratic in x in denominator. Suppose this is our y is equal to that. So we get y into 1 plus x square minus x is equal to 0. Now you see it is quadratic in x. So that yx square minus x plus y is equal to 0. And x, this x for that function, x is real. So that in the quadratic equation x is real. So its discriminant must be positive. That is, we get that b square minus 1 whole square minus 4 ac y square is greater than or equal to 0. So that 4y square is less than or equal to 1. That is 2y, that is y is, just 1 minute, that is 2y is less than 1 minus 1. That is less than or equal to. That is y is less than half from there and greater than minus half. So that minus half to half, this is admissible value of y to such that the function would be defined. So admissible value of y means function, this function is this and that. That is, range of the function is minus half to plus half. This type is important, very important. If the function is somehow can be expressed in terms of quadratic equation in x, this method is very simple, very effective and simple. Our next problem, range of sine root over of pi square by 4 minus x square, range of the function fx is equal to, and options minus 1 1, 0 1, minus half half, and minus half 0. So the function is this. It is defined only if pi square by 4 minus x square is greater than or equal to 0. That is, x square is less than or equal to pi square by 4. So that minus pi by 2 less than or equal to x less than or equal to pi by 2. Otherwise, the function will be imaginary. So, domain of definition of this function is this, from this to that, domain. Now, we have to find what within that range maximum and minimum values of the function. Minimum value of x square, it is equal to 0. So, if minimum value of x square is equal to 0, so this thing is sine of root over of pi square by 4. So that sine pi by 4, pi by 2 is 1. So its value is 1 when this is 0. 0 is within the range. Moreover, when x is equal to minus pi by 2 or pi by 2, this thing is 0. Sine of 0 is equal to 0. So, functional value of fx within that range is 0 to 1. So, this is range of the function fx. Next problem. If fx is equal to x to the power, if x minus 1 by x is equal to x to the power 6 plus 1 by x to the power 6, then f1 is options 3, minus 2, 14, 18. If x is not given, f of x minus 1 by x is equal to this given, from there we have to find f1. There are two processes. If we take x minus 1 by x is equal to 1, then solve for x. This is 1, then solve for x and put it there, then we can get answer, but it will be some clumsy one, very calculation will be tedious. Better option is we express this function is equal to this in terms of x minus 1 by x. In terms of x minus 1 by x. Then putting x minus 1 by x is equal to 1, we get answer. For that purpose, f of x minus 1 by x is equal to, this is x to the power 6, x square plus 1 by x square whole cube, x to the power 6 minus adjust 3 ab 1 into this. This can be written as x minus 1 by x whole square, x square plus 1 by x square, and adjust plus 2ab, its whole cube, minus 3 into, by same way, x minus 1 by x whole square plus 2. Now, we express f x minus 1 by x in terms of x minus 1 by x. So now by putting x minus 1 by x is equal to 1, we get functional value f1. So f1 is equal to 1 square plus 2 whole cube minus 3 into 1 square plus 2, so that it is equal to 3 whole cube, 27 minus 3, 9. So 18 is the answer. So option D is correct. Next, our next problem. If 3 of fx plus f of minus x is equal to 2x minus 2, then find the value of 2fx plus 3 f of minus x. Options: minus x minus 5 by 2, minus x plus 5 by 2, x minus 5 by 2, x plus 5 by 2. Okay. Achha. This problem is very simple and interesting. Very simple and interesting, and very important also. Here actually we have two unknown. One is fx, other is f of minus x, and it is equal to in terms of x. We have to solve for fx. If we can get fx, then f minus x automatically can be obtained. For that purpose, replace x by minus x. Sorry, x by minus x are there. So this becomes an unknown is fx and other is f of minus x. Very easily now we can eliminate by eliminating f minus x, we can obtain fx or vice versa. So for that purpose, you multiply throughout this by 3, so that this becomes 3 into f of minus x plus 9 of fx is equal to 6x minus 6. Now subtracting we get, then we cancel. So minus 8fx is equal to minus 8x plus if fx is equal to 3x plus a if x is less than 1, and it is equal to b, not 6, b minus x if x is greater than or equal to 1. If again if f0 is equal to 2, f10 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 is equal to minus 10. From this part we get b minus 10 is equal to minus 10, so that b is equal to 0. Minus 10 cancels. So now we get f of minus 2 plus f of 2. F minus 2, argument is minus 2 less than 1, so can be obtained from this part. So that it is 3 into minus 2 plus a. A means already obtained, just now it is 1, plus f2 can be obtained from there because argument is 2 greater than 1. So it is equal to b minus 6. Answer is given as minus 6. So you please check the calculations. If calculation is okay, then this one would be minus 7. Next. Next one is, let fx ax square plus bx plus c and gx is equal to we have to find 6 unknown to find the value of this and that. So f1 is equal to g1, it gives a plus b plus c. F1, put 1 over here, is equal to g1 means p plus q plus r. From there we get a minus p plus b minus q plus c minus r is equal to 0. First equation. From the information that f2 is equal to g2, I put x is equal to 2 over here and there, so that 4 into it is 2. Another relation is 9 into a minus p plus 3 into b minus q plus c minus r is equal to 0. Now, from 3 equations, 3 unknown, as if unknown is 3 unknown, a minus p, 1, b minus q, etc. So subtracting this from there, we get 3 into a minus p plus b minus q cancels is equal to 0. Suppose this is 1. Now subtract this from there, we get 5. Two. Now we have to find the value of f4 minus g4. f4 minus g4, put x is equal to 4 over this and that. So a into, actually 4a, 4 square, that is 16 into a minus p plus. We have to put x is equal to 4. So 4 into b minus q plus c minus r is equal to 16 into a minus p is equal to 1. B minus q is minus 3. So 4 into minus